Hey folks, Nathan here. In this video we're covering the Hydron v0.4 and our first attempt at a parachute. There were definitely some ups and downs with this leg of the project, and one very fast down in particular, which we'll get to later. On the 0.4 we've also increased the size of the payload bay so that on the 0.5 we'll be able to fit some electronics in. But without too much more ado, let's get into it. Starting out with our payload bay construction. So we took the top of a 2-litre bottle, cut that off, and then put the bottom half of it on top of our rocket. This gives us a nice big area to chuck our electronics in, our payload. We've still got our Velcro there on the bottom, so we can actually hold our payload in a bit better. And now here we are chucking a sort of door on the payload bay, just so that we can access it easily without having to completely remove all the masking tape to get into it and press any buttons on it that we need to. The flap on the door here is at the top, so that in theory when it flies through the air will rush past it and push the flap in, so that we don't need any latches or anything like that. And then we've just got our nose cone that we're working on, and that'll just sit on top. This design was for a loose nose cone, but for reasons we'll get into later, we are going to be moving to a fixed nose cone. And that's all for our payload bay. Let's take a look at our parachute. Right, so we did just a random drop test with this parachute, and as you can probably guess, this is way too small. And our fin broke off, but we've given it a quick repair. It was basically a clean snap down that way, which was good, made it very easy to repair. But yeah, we're going to need something a lot bigger, so we're probably going to have to go for part of a garbage bag. Let's see how that goes. So after our first parachute was shown to be just a little bit too small, we ended up using a garbage bag, and here's how that went. First off, we had to cut out our garbage bag. We ended up with a squarish shape of around 62 centimeters by 70 centimeters with a total cross-sectional area of around 0.43 meters squared. Because it's sort of curved as it falls through the air, we can probably safely assume this is closer to around 0.3 meters squared. And that gives us plenty of drag for our rocket. We then had to actually attach our parachute to the rocket, and our tool of choice here was copious amounts of masking tape. So we got our parachute cord, we masking taped it to the top of the payload bay, and then the parachute would be rolled up and put inside the nose cone, which would then sit on top. And that's how we built our new Hydron v0.4. So next up, let's take a look at how it flew. Our first couple of flights were done in twilight, mainly just because I was impatient and really keen on flying it. So some of the lighting conditions in these videos aren't the best, but you can still see parachutes coming out. Our first launch with parachute and extended payload bay. Initial tests going in 5, 4, 3, 2, 1. Oh, so good. Alright, second and final launch for tonight because it's getting a bit difficult to see. So, parachute test number 2. Launching in 5, 4, 3, 2, 1. Perfect. First daytime test of parachute. Nose cone's on quite tight, so hopefully it will deploy, but it may not. We'll see how we go. Anyway, launching in 5, 4, 3, 2, 1. We'll kick off our analysis with our 2 nighttime videos. So the thing to know about the Hydron v0.4 is that the parachute deployment mechanism was essentially just a loose nose cone, which we were hoping once it gets to apogee, the nose cone will fall off and the parachute would come out. So with our first launch, we could see that pretty early on the nose cone fell off, and that led to the parachute falling out early, creating a lot of drag, and we got a less than ideal flight path. We didn't even remotely reach the heights that we'd normally get, and we got quite a bit of tumble from that. And yeah, so definitely not the best. Our second launch went about as well, but we can kind of see what's going on this time, at least early on in the rocket flight. We can see here in the slow motion footage that just after launch, the rocket essentially flips itself 180 and the parachute comes out. So this, I'm fairly sure, is the nose cone coming off early again, but it's a bit hard to see with the lighting conditions. We can also see as the parachute comes down that our shroud lines are starting to get a bit tangled. So we may have to think about how we can overcome this in the future, but it's not a priority one at this point. Launch number 3, our daytime launch, is where we encountered a lot of our problems. So right off the bat, there was one thing that we messed up, and that was that we were facing the sun when we were filming. Normally when we're filming there, we're doing it in the morning, so the sun's the opposite direction to us. But this time we were doing it sort of late afternoon, so the sun was right ahead, and didn't actually realize that was a problem until I launched the rocket and couldn't actually see it when I looked up. So that's why we got some not very good video of that one. The next problem that we faced is that it was a quite windy day, and as we were trying to set the rocket up on the launch pad, the nose cone was continually just blowing off and the parachute was going with it, so we'd have to roll it up again, put it back on, and then hope that a breeze wouldn't take it off again. So what we should have done was take this as a sign that, hey, maybe it's too windy to launch today, and scrub it, do it again tomorrow. But instead what we did was we thought, nah, we'll just put the nose cone down a lot more solidly, and then the wind won't knock it off. And as I'm sure you can guess, having a nose cone on a lot more solidly means that the nose cone just isn't going to come off. And that's exactly what happened. We had a ballistic descent. We ended up losing 2 fins and the payload door, and also our payload managed to actually fall out of the rocket on descent. So not really sure how that happened. Since we didn't get the video, it must have just been a pretty solid crash for it to do that. So that was a fun one. We've repaired the fins, so we're good to go again, and I think we'll be moving to a much better parachute system. If there's one thing that I did learn from this experience, it's that just relying on a nose cone to fall off at the right time is not a good way of doing rocket launches, especially if you want payload in there, and especially if you're going higher than like 20 feet. So yeah, what we're going to be doing next is, instead of just doing the pure altimeter, I'm going to be putting a servo in as well and building a parachute ejection mechanism, because we definitely need something a lot more reliable for the parachute to eject, and I don't want to have to rely on chance essentially to have the nose cone fall off. So we're going to be moving to a fixed nose cone for the V0.5, and we'll be having the servo in there to actually release a parachute when needed, and that will most likely be done based on when it detects it's at apogee. And next video I'll be going into how we do that. But our deployment system definitely needs an upgrade, and that's what we'll be doing next. Alright, catch you later.